Welcome back. Here are the module 15.2 notes. This is page 6. So, example of critical value method and p-value method on the previous page. Here I am going to use the critical value method, and I'm going to explain why in just a minute. Okay. So we have example 5. In a survey, 45% of the respondents stated that they talk to their pets. So I have got a p-value of 0.45. This veterinarian believes the results to be inaccurate, so she randomly selected 150 pet owners, so my N is 150, discovered that 63 of them spoke to their pets. Does the veterinarian have enough evidence to say that the proportion of pet owners that talk to their pets is different from 45%? So different from. Okay, we got an alpha equals 0.01 level of significance. So we are going to start by checking for normality. We have our 150 times 0.45 times 0.55 gives us a 33.75, which is greater than 10. So we are okay to move on. So different from 45. So I'm going to do this in a little different order. My null hypothesis, the proportion is 45. My alternate hypothesis is that it is not 45. Here's what this looks like in terms of my normal curve. It can be down here, let's see the same color, right? Significantly less than that 0.45. It can be up here, significantly more than that 0.45. In both instances, we are going to reject H naught if our value falls within either of these regions. Okay? Because of this, I like using the classical value method. I have got an alpha over 2 of 0.005, so 0.005 in each tail. If I use norm.s.inverse to find that cutoff value for 0.005, I get negative 2.58. So I know my cutoff value here is negative 2.58, but I know my normal distribution is symmetric. So I know that up here, it's positive 2.58. Okay, I don't have to worry about finding a probability and figuring out which end it belongs in. If I get a Z data score that is either less than a negative 2.58 or greater than a positive 2.58, right, I know I'm out in those tails. So let's calculate what we need so we can figure out what our Z data score is, what our test statistic is. I got 63 over 150. I have a sample proportion of 0.42. My standard deviation for samples of this size over, how big's my sample, 150, is 0.0406. So my test statistic, let me label that. Which is Z data 0.42 minus 0.45 all over 0.0406. I get a negative 0.739. Let's think about where that would live, somewhere up here. It is not in rejection region, not in the rejection region, not in either of the rejection regions, not in either of the rejection regions. So we do not reject H naught. So do not reject our null hypothesis. We do not reject H naught. There is not enough evidence at the alpha equal 0.01 level of significance to suggest the proportion of owners who talk to their pets is different than that 45%. Okay, so let me give you 4 steps here as we write these out. So here's how we're going to format our statements. Maybe I should have done this before. They all look the same. So 1, you're going to say whether we reject or fail to reject H naught. Notice it's always H naught. It's never the alternative hypothesis. Second thing we're going to state, whether there is or is not enough evidence we're going to state the level of significance, and then we are going to round out our explanation by explaining this in the context of the problem. On your exams, you will get 4 points for this problem statement. You got to hit all 4 of those.